Today's lesson is going to be on interior angles of polygons. Here's the goal, the objective, and this should match. You're going to want your note sheet out that we've been working with throughout this geometry unit. It's going to be the last note sheet in there. It hasn't been filled out yet. The goal is I can develop and use a formula for the sum of the interior angles of polygons by breaking the polygons into triangles. Go ahead and write an essential question and then come back and we'll start filling out our note sheet for this lesson. We have two definitions that we need to get down. The first definition is for regular polygon. A regular polygon is a closed 2D shape made with straight sides. All angles are congruent and all sides are congruent. Here's an example of a regular polygon. We can see that all the sides have one tick mark. That's showing that they are congruent. And all the angles in this polygon are congruent. So that's what makes it a regular polygon. An irregular polygon is a closed 2D shape made with straight sides. This time, all angles don't have to be congruent, and/or all sides don't have to be congruent. This right here is a 5-sided polygon. This is a 5-sided polygon as well. You can see that they don't look the same, but they have the same number of sides. We call both of these a pentagon. And the reason this one might not look the same as this one is because not all sides are the same. And not all angles are the same. Here's what we're going to do. You have a chart in your notes. You have one extra column, and that extra column is just telling you how you say that polygon in words. For example, I believe the first column says regular polygons. So we're dealing with regular polygons today. And I believe the first polygon that's in that column is a triangle. So this is what we're going to do. This right here is a triangle. We're going to go ahead and fill out our chart. The column that says number of sides, well, how many sides are in a triangle? Or on a triangle? 3. The number of triangles formed. Now listen very carefully. I made your vertices very defined. You're going to pick one of them. That one vertex that you pick, you're then going to connect that one vertex to every other vertice in the shape, always picking up and going back to that main vertex. How many triangles do you see in front of you? 1. The sum of the interior angles of a triangle, well, we focused on that the other day. That's 180 degrees. Going to the next shape, that's what we call a quadrilateral. It has 4 sides. This is a regular quadrilateral, so we can refer to this shape as a square. Rectangles are also quadrilaterals, but they're not regular because not all sides measure the exact same length. Number of triangles formed, here's what we're going to do. Again, pick a vertex, and then from that picked vertex, draw a segment to every other vertice, always going back to the one vertex that you picked. How many triangles do you see? 2. How can we use this to help us find the sum of the interior angles? Well, we know that the interior angles, the angles on the inside of a triangle, add up to 180 degrees. So I can go 180 degrees times 2, or 180 degrees plus 180 degrees, to find the sum of the interior angles of a quadrilateral. Which, when you add those together, you get 360 degrees. This is a really common one to know the sum of the interior angles. Our next polygon is a 5-sided polygon, which we call a pentagon. You'll see that in your notes. You might not know the sum of the interior angles for a pentagon. It's not something that's in your everyday knowledge or part of your everyday knowledge. And that's okay. We can use this strategy of using triangles to help us figure that out. So the number of sides on a pentagon, you can count them 1, 2, 3, 4, 5. Number of triangles formed, again, pick a vertex. And then from that vertex, draw a segment to every other vertice, always going back to the main one that you picked, so that we're not crossing over and creating angles that aren't there. You'll see that we created 3 triangles. Each one of these triangles, the 3 angles, add up to 180 degrees, so we can use that to find the sum of the interior angles, the angles on the inside of the pentagon. Take 180 and multiply it by 3. When you do that, you'll find that you get 540 degrees. You have one more polygon on the front side of this note sheet. That's hexagon. And then you have a back side. You're going from hexagon to heptagon to octagon to nonagon to decagon to n-gon. You have permission right now to leave n-gon blank. We'll do that together after you finish hexagon, heptagon, octagon, nonagon, and decagon. For those shapes, you need to do exactly what we did here. Draw the triangles on the inside. Fill out the rest of the chart. Again, you can leave n-gon blank. We'll come back and we'll do that together. Let's check your work. We did triangle, quadrilateral, pentagon together. You already have those recorded. Let's check, because you had to start with hexagon all on your own. Hexagon has 6 sides, 4 triangles were formed, and you should get 720 degrees. Heptagon has 7 sides, 5 triangles were formed, and you should get 900 degrees. Octagon has 8 sides, 6 triangles were formed, and you should get 1080 degrees. Nonagon has 9 sides, 7 triangles were formed, and you should get 1260 degrees. Decagon has 10 sides, 8 triangles were formed, and using those we got 1440 degrees, which is what you should have as well. Make sure your note sheet has this information on it. Now, what in the world is an n-gon? Well, n stands for any number-sided polygon. For example, a 12-sided polygon, you might not know the professional name for it. You can call it a 12-gon. 15-sided polygon, you might not know the professional name for it. Mrs. Kluger doesn't. You can call it a 15-gon. A 20-sided polygon, you can call it a 20-gon. So this n right here stands for the number of sides that the polygon has. So in the column that says number of sides, go ahead and put the letter n. N stands for the number of sides. It can be any polygon. How do we figure out the number of triangles if we know the number of sides? Well, look right here. How do we figure out the number of triangles for these polygons that we did? Do you see a pattern happening? 3 to 1, 4 to 2, 5 to 3, 6 to 4, 7 to 5. You're taking the number of sides and you're subtracting it by 2. So down here, for any sided polygon, if we want to figure out the number of triangles formed, we take the number of sides and we subtract it by 2. The number of sides is represented with our variable n. So we have the expression n minus 2. We can plug in any value here for n. So let's say it's a 17-gon. We can plug in 17, because that's the number of sides, subtract 2, and we would know that 15 triangles would be formed in that polygon, which is critical, because the triangles help us figure out the sum of the interior angles. So now going to the last column, how can we use this information right here to find the sum of the interior angles? Well, we first have to know how many triangles are formed in the polygons. So we need to go n minus 2, and then multiply that by 180. To make sure that we do n minus 2 first, what do we have to put around it? Our grouping symbol. Otherwise, order of operations would tell us to multiply first. So right here we have n minus 2 in parentheses. That gives us how many triangles are formed in the polygon, times 180 degrees, because there's 180 degrees in a triangle. This is the sum of the interior angle formula. You can pick any type of polygon. Let's put this expression to the test. If this is the formula that we can use to find the sum of the interior angles for any polygon, let's pick a 17-sided polygon, so a 17-gon, and find the sum of the interior angles. If I have a 17-gon, what am I going to plug in for n? Well, 17-gon is telling me that that polygon has 17 sides, and n stands for the number of sides. So I'm going to plug 17 in for n. Now we use order of operations, grouping symbols first. 17 minus 2 is 15. Fill in what I haven't done, times 180 degrees. So this 15 right here is telling me that I have 15 triangles in a 17-gon. And each one of those triangles measures 180 degrees with its 3 angles. So I can use that to find the sum of the interior angles of a 17-gon. So 15 times 180 degrees, that gives you can use a calculator, 15 times 180, 2,700 degrees. That's the sum of the interior angles, the angles that are on the inside of a 17-gon.